So today we're going to look at another business application for derivatives. The main thing we're going to look at is something called elasticity of demand. But before we get to that, I want to review what demand is. Now, you should have probably talked about this in Business Math 1 a little bit, but probably more in your basic economics class would you have talked about demand. So it's a basic price equation involving the number of units demanded X. So we always call X the number of units demanded. And so an example of a really simple demand equation might look something like this. This is a linear demand equation. Notice we use lowercase p when we want to talk about price. We use capital P when we want to talk about profit. So those are pretty standard variables that you'll need to know. So the first formula that we're going to talk about today is the relative rate of change of a function. So rather than just talk about the rate of change, this compares that back to the original quantity, okay, or the original function. So this is the main formula for relative rate of change, f prime of x over f of x. But your book gives an alternative formula that I think is a little more confusing, to be honest, but I'm going to go ahead and give it to you just because I think help features in my math lab might feature this, so I want to make sure that we don't get too confused there. Okay, but this is the one that I really want you to focus the most on. It's the derivative over the original function. Notice that would be the same thing you would get here, by the way. Okay, using chain rule, if you did the derivative of natural log of f of x, you would get 1 over f of x, and then times the derivative of the inside, and the inside is f of x. Okay, so just a little too confusing in my opinion. So this is what you get when you do the derivative of this. So let's just remember it this way. So let's find the relative rate of change. And let's use this function, f of x equals 4x squared minus the natural log of x at x equals 2. For all of these answers, let's just say we're going to round to 3 decimal places. Make sure you read up on your homework. It'll always try to tell you how many decimal places it wants. Okay, but I'm going to want 3 for the ones we're doing in class today. So the relative rate of change then would just be whatever the derivative function is over the original function. Okay, so let's find the derivative. We should be able to do this without doing too much work, right? The derivative of 4x squared is 8x. This is one of our special cases from the last unit, right? The derivative of ln of x is 1 over x. And then on the bottom just goes whatever the original function was. So this would be the relative rate of change formula right here. Okay, but notice we're given a specific x to look at, so let's see what happens when we plug in 2. Okay, so we're going to do f prime of 2 over f of 2. So f prime of 2 will plug 2 into the derivative. F of 2 will plug 2 into the original. So if you work the top and bottom out on your calculator as far as they can go, before you have to start approximating, this is what you'll get. But in the end, I think this does ask for the decimal version that it rounds to. Okay, so remember this symbol means approximately, so that's the one I want you to use whenever you're rounding an answer. So we can talk about relative rate of change, and we can also talk about percentage rate of change. And that's just where you describe the change in percentage form. So to be honest, you don't really do much different. The formula for percentage rate of change is just 100 times f prime of x over f of x. Okay, but that's how you always change a decimal to a percentage anyway, right? So that's what I'm saying. It's not really its own formula. It's really just taking the decimal you get in relative rate of change and moving the decimal twice in order to change it to a percent. But let's go ahead and practice one. So let's find the percent rate of change of the first example. So notice we would just take the decimal we got in number 1 and multiply it by 100. Or remember what I said, you can also just move the decimal place over twice, but you get 103%. Okay, sorry, not 103, 101.3%. In other words, the value is increasing by quite a bit in this problem. All right, so this next one I want you to try on your own. So once I'm done giving you the question, I want you to pause the video and see if you can kind of jot it down and see if your answers match up with mine. So I want you to find both the relative rate of change and also the percentage form. So the relative rate of change and the percent rate of change. For f of x equals, let's do 3,000 minus 8x squared. And let's say that the x value I'm choosing is 12. Okay, so pause the video and see what you get here. All right, so I've got f of x equals 3,000 minus 8x squared. I'm going to go ahead and plug in f of 12 because I'm going to need that in my calculation. So if you work that out on a calculator, you get 1848. But notice the original function is used in our formulas, but also the derivative. So let's find the derivative also. The derivative of 3,000 is just 0, right? The derivative of negative 8x squared is negative 16x. So now let's find that value with 12 plugged in. So if you multiply that out, you get negative 192. Okay, and then you can just plug them in the formula, right? So the relative rate of change at x equals 12 is going to be the derivative at 12 divided by the original at 12, and we already figured both of those out. So it would be, in this case, 192 over 1848. And if you work that out on your calculator, you'll get negative 0.104. Okay. In other words, this indicates that we have a reduction in the value, right? So the rate of change here is, or the relative rate of change is negative, which means the values are getting smaller. So if you do 100 times negative 0.104, you get negative 10.4%. So compared to the original values, the derivative or the rate of change is reducing by negative 10.4%. All right, so let's see if we can kind of look at a case study and see what we can talk about with the rate of change. So describe the change in revenue. And let's say here are the scenarios we're working with. The current price of a hat that our company is selling is $8. And at that price, 6,000 hats are demanded by the consumers. But let's look at scenario B. If we instead charge $12 for the hat, then if you're using kind of logic, right, if we charge more for the hat, then less people are going to want to buy it typically. That's one of the principles of economics. So let's say that only 4,000 hats are demanded in that case. So taking these two scenarios into account, let's say that we want to increase. So we, on the production side or on the sales side, are trying to decide, do we want to increase the price per hat by $1? But there's always a give and take in economics, right? So when you raise the price, you've got to know that your quantity demanded is likely going to go down. So your goal as a marketing person or as a salesperson would be to figure out, can I afford to raise the price of this, or will it drop my demand by too much? All right, so the question is, should the business owner increase the price? Okay. Is it too risky to increase the price by $1, or will we see a higher revenue if that happens? All right, so let's look at scenario or option A. Okay, so let's talk about what the current revenue is. Now, back in the last unit, we talked about an easy way to find revenue. So think about that. If you're selling hats, what two things are you going to need to know to determine revenue? You're going to need to know how much you charged for the hat, right? And then how many hats you sold. So in scenario A, we're charging $8 a piece, right? And when we do, we sell 6,000. So notice that would be revenue of 48,000. Okay, make sure you don't confuse that with profit, right? This is revenue. That just means the money that's brought in. We're not taking into account costs or anything like that, just revenue. All right, so let's talk about what happens after the price increase. So somebody in sales, somebody in marketing is wanting to increase the price of the hat by $1, right? So in other words, we're going to bump the price of that hat up to $9. But when we do, our demand is going to go down by 500. So instead of 6,000 being the quantity demanded, now we're only demanding 5,500. And so the question is, would that be a good move for option A? Okay. Notice we have an increase in price. Sorry, not price, but revenue. So notice the increase in revenue. So in this scenario, we would want to increase the price. Okay, it's worth it, right? We're going to make more revenue if we do that. Even though we sell less items, it's worthwhile for us to increase the price and take a hit on selling 500 less hats, basically. Okay, so let's look at option B. Option B, remember the current selling price is 12. So if we want the current revenue, we'll take the 12, and there are 4,000 hats demanded. Okay, notice it's the same 48,000 that we started with in option A. But now let's talk about what happens after the price increase. So if we increase the price of this scenario by $1, now the hats are costing $13 each for our customers, right? And we're only selling 3,500 because we reduced the quantity again by 500. And so notice this only makes a revenue of 45,500. Okay, so notice that this causes a decrease in revenue. So if you're the business owner, or if you're the sales department trying to make this decision, you would probably advise, no, don't increase the price at this level. Okay, so this basic example is really what we're talking about today. So when I mention the term elasticity of demand, I'm about to define it in a minute, it really just means how flexible is the demand? Am I allowed to change the price, and if so, by how much? Or is that going to affect demand too much? Is that going to cause a decrease in my revenue like it did in option B here? Or is that going to cause an increase in my revenue? Okay. And so before you would go changing prices of things, that's something you would need to know in the real world, right? So, or you would want someone at your company to know at least. Okay. Maybe you don't have to know, but somebody has to know. Okay. So that's what elasticity of demand is. It's a ratio that describes changes in price related to changes in demand. Okay, so how flexible are we in what we charge for something? Okay, and you're going to find that, especially in real life settings, the more people need an item, the more you may be able to go up on the price, right? I mean, gas is a really good example, right? I mean, people will drive less if you increase the gas prices to crazy amounts, but they're not going to quit using gas altogether, right? We need gas, okay? Things like in the grocery store, like milk and eggs and cheese are pretty, able to be raised in price because we need those things, okay? Whereas maybe things like soda or chips, people don't, quote, need those. So if the price goes up too much, you might say, hey, I'm not buying my Fritos this week or something, okay? So the formula for elasticity of demand, we call it E of P, little p meaning price, is always going to be a negative sign, and it's going to be the negative rate of change of demand and then over the relative rate of change for price. Okay, that's essentially what we're finding. I like this form better. This is an equation that'll get you there. So it's negative P times F prime of P and then divided by F of P. Okay, so this is the formula we're going to be using most often for elasticity of demand. And then we're going to talk about kind of what the meaning of our answer is after we practice maybe finding it once. Okay, so let's look at an example. So let's say that the price P and the demand X are related by the equation X plus 500P equals 10,000. Okay, so this is the pattern that exists in whatever company this is. And so I want you to find the elasticity of demand. This is just going to be a number, by the way. And then we're going to talk about what the numbers mean here in a bit. All right, so I want you to find 3 elasticities of demand. One when the price is $4, one when the price is $6 or $16, sorry, and then one when the price is $10. All right, so the first thing you need to do before you really even start is you need to solve for x. Okay, in other words, our equation needs to look like demand equals something. Okay, so we're going to take our x plus 500p equals 10,000, and we're going to subtract 500p. So we're going to get, of course, x equals 10,000 minus 500p. Okay, so another way that we can write this is we could say that f of p is this equation. Remember, f of p just means it's a function involving p. That's really all it means. Okay, so notice we could now take the derivative of that, right? What would be the derivative of 10,000? It'd just be 0, right? The derivative of negative 5,000 or 500, sorry, p would just be negative 500. So let's come up with our elasticity of demand equation, and then we'll plug in the numbers when we're finished. So this is the formula we use. Okay, so now let's just plug it in. So we're going to get negative p times what we got for the derivative, which was in this case just negative 500, and then over the original function, which was 10,000 minus 500p. So if we clean that up just a little bit, we'll have 500p over 10,000 minus 500p. So I'm going to circle this just because that's the equation we're going to use. By the way, don't do anything goofy and try to cancel out 500p's. You're not allowed to do that. You only can cancel things like this when there's something in everything. So technically we could simplify this a little bit, but I don't really think it's really necessary to understand this problem. So I'm just going to leave it as is. So let's find E of 4. So we're going to get 500 times 4 over 10,000 minus 500 times 4. So if you work this out, you're going to get 2,000 over 8,000, or 1/4. Typically you'll write this as a decimal, so that would be 0.25. Okay, notice I don't use the approximate symbol because 1/4 actually is 0.25. So when the price is $4, the elasticity of demand is 0.25. Okay, what about when the price is $16? Then we do 500 times 16 over 10,000 minus 500 times 16. So you end up getting 8,000 over 2,000. So kind of the flipped version that you got for number 1. So that works out to just be 4. And then last but not least, E of 10 is going to be 500 times 10 over 10,000 minus 500 times 10. So notice you're going to get 5,000 on top. On the bottom, you're going to get 10,000 minus 5,000, which is again 5,000. So you actually just get 1 here. All right, so let's talk about what the meaning of these are. So I'm going to put a star by this. So you'll want to have your notes out as you look at the homework and stuff like that. But if you get, don't let this throw you off. This just means the elasticity number that you get or decimal is between 0 and 1. That's all it means. It's sandwiched in between. Okay. This means that the demand is what we call inelastic. So I'm going to underline that. Okay. Inelastic means that the demand is not sensitive to changes in price. In other words, it might be something like gas or milk or eggs that people are going to kind of probably not change how much they buy, even if it's more. Okay, so in situations like this, if demand is not going to be reduced much or at all when you increase the price, then that means that an increase in price will definitely increase revenue, right? In other words, if you're not going to make people not want to buy your product by raising your price, then raising your price should have a good effect on your bottom line if you're the business owner. Okay, we're looking at this from the perspective of the business owner, not necessarily the consumer. Okay, although the consumer kind of decides what happens here, right? Because they decide if they're willing to buy your product for more. So if the elasticity of demand is something larger than 1, this means that the demand is elastic. Think of it this way. If something's inelastic, like if something can't be stretched, right, that means it doesn't move a whole lot. If it's elastic, like a rubber band, then it means it moves, right? So it means that the demand would change. So the demand is sensitive to a change in price. In other words, people are really going to react if you change the price of a product like this. So basically, an increase in price might not be the best thing for you to do as the business owner because it will usually decrease your revenue. In other words, you've made your consumers be like, nope, that's it. I'm not buying that product anymore. It's too expensive. Okay, there does come a time in most products where you're charging too much and they just won't buy it anymore. And then the last scenario is if it is exactly 1. Okay, if it's exactly 1, it means that you have a unit demand. Okay, so if you get 1, it just means that basically price increases will have no effect, okay? Because as you increase the price, the demand is adjusted in kind, okay? In other words, the ratio of the two is 1. So yes, there are some decreases in demand, but it decreases by the same percentage as the price goes up by, okay? Which means the revenue is not going to change. Okay, so if you're the business owner in this scenario, I guess you would have an option whether to increase the price, but it really wouldn't make that much of a difference for you, right? Because you wouldn't be making any more. All right, so in other words, in the last example, okay, so I'm going to slide this down. In the last example, if we're charging $4 for whatever it is, then it means we get something in between 0 and 1, right? So the demand is inelastic, which means we could afford to increase the price when we're only charging $4. Notice if we're already charging 16, though, the demand is elastic, right? In other words, we're already charging kind of a lot for the items, so at this stage, we wouldn't want to increase the price because it would actually decrease our revenue. It makes the demand change by too much the other way. And then when the price is 10, you're at a really level spot, right? So if you increase the price at a price of 10, by $1 or $2 or something, it's probably not going to make that much of a difference in your bottom line. So in my opinion, kind of why do it in that scenario? All right, so I want you to use the numbers in example 5 so I don't have to introduce a whole new one. And I want you to discuss what would happen to demand in each of the scenarios if the price changes by 10%. And we're going to assume that it's an increase in price, not a decrease in price. In other words, we're going to assume that that's a positive 10%. All right, so let's just set these up. Let's see if we can do these side by side. So remember, the first scenario was the price was $4. The second scenario was the price was $16. And then finally, the last scenario was the price was $10. Okay, so all you do is you take that elasticity of demand and you just multiply by 10%, okay, because that's what the problem tells us to do, right? So you're going to take that 0.25 that you got from example 5a and you're going to multiply by 0.1, okay? It's 0.1 because remember 0.1 represents 10%. So if you multiply that out, you get 0.025, okay? Or let's change it back to percentages, right? 2.5%. Okay, so I'm going to circle that, and then let's kind of briefly describe what this means. So if the price changes by 10%, then the demand does change, but it doesn't change by as much. It only changes by 2.5%. Okay, so think of these like opposite directions, right? The price is going up by 10% and the demand's only going down by 2.5%. So that's why we would say you're kind of safe to do a price change here, because the demand is going down by less than the price is changing by. All right, so let's do the next one. Remember, the answer we got for elasticity of demand for price being 16 was $4. So we get 40%. Okay, so notice I would be alarmed if I'm the business owner here, right? So if I bump my price up by 10%, because that's what it is for all these parts. So if the price changes by 10%, then the demand changes by 40%. And remember, that means it's going down by 40%. Okay, so that's too risky, right? We wouldn't want to increase the price by 10% if we were going to lose 40% of our demand or 40% of our sales. That would be a really bad business move. And then last but not least, if we do 1 times 0.1, okay, by the way, it's 0.1 always because it's 10%. Okay, if it were 15%, it would be 0.15. If it were 20%, we'd be doing it by 0.2. But this works out to be 0.1. Notice there's no change in percentage, right? And there's no change in percentage because it's unit elastic, right? So that means if the price changes by 10%, then so does the demand. So in other words, nothing really happens to your bottom line, right? Because we're increasing one and decreasing the other by the same quantity. Okay, so again, inelastic, elastic, unit. Okay, that's the order there. Okay. Okay, so let's look at some scenarios that you might see on your homework. Some of them are actually really easy questions, but sometimes those are the hardest, right? Because you're like, it can't be that easy. So let's look at a few of those. A restaurant, let's say a restaurant can produce a burger for $2.50. If sales increase by 30 burgers a day, how fast is the daily cost increasing? So notice, we actually already have all the information we need, and we don't even really need a formula for this, okay? Every single burger is costing the company $2.50, so if you increase sales by 30, how fast is the daily cost increasing? Well, you would just take 30 times each one of them cost an extra $2.50, right? And so it would be $75 per day, okay? So I'm going to say this. It's $75 per day on top of what you were already doing, right? Because it's, you know, we're increasing by 30 burgers. Okay, so whatever the cost was before, we're adding $75 to that because we're making 30 more burgers. Okay, so sometimes the problems, you know, really are kind of that simple. Just asking you to use a little bit of common sense on that one. But then sometimes we're going to want kind of a full-blown formula used. So let's say the price demand for, let's just stick with the restaurant example. An order of fries is X plus 1,000 P equals 2,500. And let's say that currently the fries sell for 99 cents. And so my question is, if the price is decreased, I'm going to underline that because we just did one where it increased, by 10%, will the revenue increase or decrease? Okay, so think about this logically. The only reason a business owner would want to decrease the price is if they thought that they were going to sell more items at a cheaper price, right? So that would be the only reason that we would want to know that. So we need to know how elastic this price is, right? Like how much does the demand react when we change the price? That's what we need. And for that, we use the elasticity of demand formula. Okay, so before we kind of plug all of that in, let's talk about it off to the side. F of P, remember that would mean solve for X, is going to be 2,500 minus 1000p. So the derivative formula would just be, derivative of this is 0, right? The derivative of that is negative 1000. So E of p is going to be negative p times the derivative formula, which is negative 1000, and then over the original f of p equation. So we get 1000p over 2500 minus 1000p. Okay, so here's the formula that will tell us what elasticity is, and now we just need to consider it at the price that we are charging for the fries right now, which is 99 cents. So if you plug that in, you're going to get 1000 times 99 cents over 2500 minus 1000 times 99 cents. Okay, notice that we get about 0.66 if you work that out on the calculator. So when we do E of 0.99, we get around 0.66. Okay, so what you need to pay attention to is this amount, go back to your A, B, and C options, right? Is it equal to 1? Definitely not, right? Is it larger than 1? No, right? Notice it's the first one, choice A. Notice that our elasticity of demand is somewhere in between 0 and 1. Okay, so what that means is, so the demand, go back and look at the terms, right? That means the demand is inelastic. Remember that means, it means it doesn't stretch much, right? So as the price decreases, so think about that. So what that means is as the price decreases, the revenue is also going to decrease. So when it's inelastic, an increase in price means an increase in revenue, okay? But when you're decreasing the price, the revenue will also decrease, okay? So a good way to think of it is when the demand is inelastic, the price and revenue will kind of go the same way, okay? When it is elastic, the price and revenue go different directions, as one goes up, one goes down. And then when it's unit, the revenue stays the same.